So jumping straight in with our Unicast routing lab, and what we're going to start off with is static routing. And what you find is with static routing is that it's just a manual way for one router to reach a certain destination. But the main disadvantage with static routing is that there's no dynamic alternative. So if you do a static route and that path goes down, then it doesn't dynamically fail over to an alternative path. But let's have a look at our topology, and it's going to be a very simple topology that I'm going to be using. I've just got two routers, two switches, Nexus 1 and Nexus 2, and they've got two loopbacks, 1.1.1.1/32 and 2.2.2.2/32. And what we're looking to do is ensure that Nexus 1 can reach Nexus 2's loopback and Nexus 2 can reach Nexus 1's loopback. And I have the switches already open, so let's look at Nexus 1, and I've already done the IP routing, so we should be able to ping our directly connected interfaces. So if I ping 10.1.12.2, which is Nexus 2's directly connected interface. But if I was to try to ping Nexus 2's loopback, guys, I have a request from you. If you're enjoying the free content, I'm looking to increase my subscriber count to 4,000 subscribers by June. But I can only do that if you give me the play special. Do you want to know what the play special is? Press like and subscribe. Okay, back to the video. We can see that we've got no route to the loopback. And this is what our static route is going to achieve. So if I jump onto onto Nexus 1, let's stop that ping. And if I say conf t, and all I'm going to do is an IP route. So IP route to get through the 2.2.2/32 network. And on the Nexuses, what you do is the exit interface and also the next hop. This is actually Cisco's best practice. You can just do the next hop interface, but we'll follow the best practice guidelines. So if I were to say Ethernet 1/1 and the next hop is 10.1.12.2. And also we need to do the same on Nexus 2. Conf t IP route to get to the 1.1.1.1/32 network. We leave out of Ethernet 1/1 and the next hop is 10.1.12.1. And there are different values on the end. So if I do, let's say it has a preference value of 25. Now if I do a show IP route, we can see we could get to 1.1.1.1 via 10.1.12.1, and we have this 25 value here, which is the preference, but we will see that on the Nexus 1, the default is different to that. If I say show IP route to get to 2.2.2.2, we see that we go out of Ethernet 1/1/1, but our preference, which is our administrative distance, is only 1. Okay, that's it for static routing. Before we move on, let's just make sure that we can actually ping 2.2.2.2 with a count of 10. And we aren't able to ping it. Why is that? Let's just stop that. And let's see why we're not able to ping. Show IP route to get to 2 via 10.1.12.2. Ping 10.1.12.2. We're able to ping it. Let me just look to see if I've got those loopbacks configured. Show IP interface brief. So on this side we have loopback 1.1.1.1 configured. Let me have a look on this side. Show IP interface brief. And we don't have the loopback configured on Nexus 2. So interface loopback 0, IP address 2.2.2.2/32. That should be all I need. Let's go back to R1 and try and ping. Let's say ping 2.2. Yes, and it is reachable. It is now able to ping. All right, the next thing that we're going to look at is EIGRP. Moving into the next part of Unicast routing, we're going to be looking at EIGRP. And what I want to do is, first I need to remove the static routes so that we don't have reachability. So if I just say no IP route to get to 1.1.1/32. I wonder if that's enough. Nah, okay. Ethernet 1/1. Next hop was 10.1.12.1. That's removed it on that side. And on this side, if I say the same type of thing, no IP route to get to 2.2.2.2/32 out of Ethernet 1/1, which is the next hop of 10.1.12.2. Okay, and if I do a show IP route for the network of 2.2.2.2, I should have nothing. Yeah, the route is not being found. Okay, so what we're going to do, we're going to move into EIGRP. And there's a few facts that I'm going to rattle off in regards to EIGRP. So EIGRP combines the benefits of distant vector protocols with the features of link state protocols. EIGRP sends out periodic hello messages for neighbor discovery. And once EIGRP learns a new neighbor, it sends a one-time update of all the local EIGRP routes and route metrics. The receiving router calculates the route distance based on the received metrics and the locally assigned cost of the link to that neighbor. EIGRP sends incremental updates to only those neighbors affected by the route change. This process speeds convergence and minimizes the bandwidth used by EIGRP. A lot of spiel there. The main things that I think of when I'm doing EIGRP is that EIGRP is a Cisco proprietary routing protocol. Now, actually, Cisco did release it as an open standard, but they removed some of the functionality. So they moved out the options of stub routing, and I think they also moved out the option of using EIGRP for DMVPN. So the IETF were like, nah, that's not good enough. So at the moment is Cisco proprietary, and which other vendors really would want to use it if you've taken out like some of the best features? And there's other things that I think of, like the dual algorithm and stuck in active and feasible successors. But we'll probably go over those more in the bootcamp. But just to get the configuration going, we're looking at, for this purpose of this particular lab, we're just looking at how R1 can ping R2's loopback using EIGRP. So we're going to look at that, and the first thing that you need to do on the Nexus is actually enable EIGRP. So if I was just to say show feature here, and it says that it's already enabled. So let's pretend that we didn't see that. So what it should be is show no feature EIGRP, and this is what you should see. Show when you do show feature. We see that EIGRP is disabled. So, oh no, EIGRP is disabled. So what we need to do is enable EIGRP. Feature EIGRP. And I'm going to do a no feature EIGRP on the other side, even if it isn't, just to show you everything step by step. So first thing that we do, we enable EIGRP, and there's a couple of ways that we could actually configure EIGRP. The first way is, you could say the traditional way of like EIGRP 100, which is called the numerical option, but you could also do like alphanumeric option, which is like test 1. So router EIGRP test 1. I'm going to use the loopback address as the router ID. So let's say router ID is 1.1.1.1. Oh, extra dot at the end. And if I now do a show IP EIGRP, we can see that the EIGRP process is configured. So if I now go into interface E1/1 and say IP router EIGRP test 1, I'm also going to configure it on the loopback, interface loopback 0, IP router EIGRP test 1, and I'm going to do the same on the other side. Feature EIGRP router EIGRP, call that one test 1 as well. And then for the interface E1/1, I wonder if I could do this and also loopback 0. Okay, maybe not then. IP router EIGRP test 1, and for interface loopback 0, the same. Now if I do show IP EIGRP interface brief, we can see that the interfaces have been configured, but we don't have any peers. Why is that? So show IP EIGRP. Alright, and I currently see that it is shut down. And the reason why it's shut down is if you configure an alphanumeric name where it can't automatically determine the autonomous system, then you need to configure an autonomous system. So if I now say router EIGRP test 1, and let's say the autonomous system of 100. Now if I say show IP EIGRP, we can see that this one is currently running. I need to do the same on the other side. So router EIGRP test 1, autonomous system is 100. Now when I say show IP EIGRP, we can see that the status is running. We have 2 interfaces and we have 1 EIGRP peer. And to further verify that, if I say show IP EIGRP interface brief, and we can see that we have 1 peer. So theoretically, I should be able to ping R2's loopback now, ping 2.2.2.2 with a count of 10, and it is reachable. Okay, another thing that I'm going to do for EIGRP, and I'm only going to cover one more thing quickly, and what we'll find is that when I do the bootcamp, if you want to see the bootcamp, go across and visit www.routercoach.com and go on to I'm All In. If you go into the I'm All In package, then you'll see the options that you can actually join the bootcamp, but you have to go on the I'm All In package for the yearly subscription. But enough of that. On our bootcamp, we will be covering things like stub routing, redistribution, wide metrics, how to manipulate K values, summarization, load balancing, and other things in regards to EIGRP. But if you're not interested in any of that and you just want to get EIGRP up and running, then this video is enough for you. But I am going to look at one other thing. So under EIGRP, it has capability to run IP version 4 and IP version 6. Now, if you wanted to run IP version 4 parameters, you just say under the router configuration here, you say address family IP version 4 Unicast. Press enter. And you have the same option to say address family IP version 6 Unicast. And what we're going to do here, we're just going to have a quick look at authentication. So if I've done this a bit the wrong way around, but if you just follow along with me, you should usually follow a couple of steps. So you would make a keychain, and then you would name the key, and then you would put in a password. Actually, let me do that so I don't confuse you. I'll go through the proper steps. So for authentication, which means that you're going to authenticate the packets between the neighbors. At the moment, if I say show IP EIGRP neighbors, we can see that we have a neighbor to Nexus 2, but we're going to authenticate that packet. So what should happen is our neighbor should drop we should stop having reachability to Nexus 2's loopback until we do authentication on the other side as well. Now the steps are, we'd say first keychain, and then we name our keychain. I'm just going to say EIGRP key. I'm going to say it's going to use key 1, and then we need a password that both sides are going to have. I will say something like key string, and I'll just call it Nexus. Our key string is going to be Nexus. Now we've got our keychain, which key we're using, and our key string. Then we could do the configuration. Now this authentication can be done per interface or under the address family, but because I want to show you the address family, I'm going to do the configuration there. So router EIGRP test 1 address family. If I do a question mark here, you can see that we could do IP version 4 or IP version 6. I'm going to do the address family for IP version 4. So IP version 4, Unicast. Then we need to choose our authentication mode. I will say, well, our authentication mode is MD5. And then we need to choose which key string we're going to use, which keychain. So authentication keychain, and I called it EIGRP key. That should actually bring our neighborship down. So if I now show IP EIGRP neighbor, we see that we don't have any neighbors. And this is because we need to actually do the same configuration on Nexus 2. So let's do that. So let's exit out of this. We're going to call our keychain the same, which is EIGRP key 1. Need to have the same key string on both sides, and that was Nexus. Router EIGRP test 1 for the IP version 4 address family, IP version 4 Unicast. And then we say authentication mode is MD5. I wonder what authentication modes they have. Only MD5. Okay, so you have to use MD5. And authentication keychain is EIGRP key. Show IP EIGRP neighbors. Our neighborships have now come back up. Let's try and ping 1.1.1.1 with a count of 10. And there we go. All right, that's it for EIGRP. As I said earlier, if you want to see anything more, jump onto www.routercoach.com, and when we do our bootcamp, we will go into EIGRP at a whole new level. But that's it. I'll see you in the next video, and we'll be covering OSPF. So 2 down and 2 to go in regards to unicast routing. So this is the topology I'm going to be using. I'm going to be using the same topology, except I've got a few modifications. As you can see, Nexus 1 now has an additional IP version 6 loopback, as well as Nexus 2, and we have IP version 6 running between Nexus 1 and Nexus 2. So let me open up those devices now and do that configuration. So on Nexus 1, interface 1/E1/1, we'll have IP version 6 address of 10:1:12:, sorry, that should be a 12, :1/64. And on the loopback, interface loopback 0, IP version 6 address of 1:1. I will just make it short actually, :1/128. And let me do the same on Nexus 2. So for interface E1/1, let me say IP version 6 address of 10:1:12:2/64. And on the loopback, interface loopback 0, IP version 6 address of 2:2:2/128. What I'm also going to do, I'm going to remove the EIGRP so we don't have any conflicts. So feature EIGRP, I actually want to say no feature EIGRP. That should remove most of our configuration, if not all. And we do the same on Nexus 1. No feature EIGRP. And let's say show run interface E1/1. So we can see on E1/1 we have an IP version 4 and an IP version 6 address. And if I try to ping the other side now, and to ping on IP version 6 you need to say ping 6. To ping the other side is 10:1:12:2. Come on, yep. And it is able to ping the directly connected interface, but we shouldn't be able to ping the loopback of R2, of Nexus 2, sorry, 2:2:2. No route to host is exactly what we want to see as well. It's a bit different to stop the pings on a Mac, but that's something I'll find a bit later on. Okay, so what we want to do, I want to do the OSPF configuration and for IP version 4 initially, and that is why I've put on the IP version 6, because unlike EIGRP and ISIS, we needed a brand new protocol to advertise IP version 6 with OSPF, and that is called OSPF version 3. But let's start off with OSPF version 2. If I say feature OSPF to enable OSPF, and then I would say router OSPF1, that enables the OSPF feature. And then what we can do is, like we done previously, we could actually do a router ID here as well. So our router ID is going to be the loopback. Let's say 1.1.1.1. And now under the interface, for interface E1/1, and before I continue with that, let me just say show IP route to get to 2.2.2.2. We don't currently have a route for 2.2.2.2. So now I'm going to say IP router OSPF1, and it's going to be in area 0. We could also do alphanumeric here, so it doesn't have to be OSPF1. It could be IP router OSPF data center, for example. But I'm going to use numerical values now. And under the loopback, I'm also going to advertise the loopback on the OSPF1 area 0. And then I'm going to do the same on Nexus 2. Feature OSPF router OSPF1, and then for interface loopback 0, IP router OSPF1 in area 0, and the same for interface E1/1. And we can run the same kind of commands, show IP OSPF neighbor. And we can see that we've got a neighbor come up. I didn't actually put the router ID on this side. Let's say show IP OSPF interface brief. And we can see that both those interfaces have been advertised as well. So the last thing we need to do is actually try to ping 1.1.1.1. Ping 1.1.1.1. And we can see it is pinging. But if we were trying to ping the IP version 6 address, ping 6 1:1:1, we can see that we are unable to ping the IP version 6 address. Now, to actually be able to do that, what I need to do is the new OSPF configuration. So if I say now, router, and we have to actually enable this feature as well. So feature OSPF version 3, and the configuration is similar. Router OSPF v3. I'm going to use the alphanumeric now. So we're going to say test 1. Now with OSPF version 3, you have to enable the router ID, but the router ID is not a IP version 6 address. It will still be a 32-bit IP version 4. So router ID is 1.1.1.1. And if you don't enable this, I don't think it will come up, but it's something you can test. Now we're going to say interface E1/1 IP version 6 router OSPF version 3 test 1, and that's going to also be in area 0. And the same for the loopback, interface loopback 0. And then we're going to do that same configuration on Nexus 1. So feature OSPF v3 router OSPF version 3 test 1. Sorry, what did I put as the router ID on this side? That will have to change. So actually I will just put the router ID. The router ID can be a random number. So it'll be 1.1.1 on that side. And on this side, I will make it, even though it's confusing, we shouldn't do that. But I'm going to make the router ID 7.7.7.7. Okay. And interface E1/1 IP version 6 router OSPF version 3. It's going to be called test 1, and that's going to be in area 0, and the same for the loopback. Interface loopback 0. Now let's say show IP version 6. No, wait, show IP OSPF version 3 neighbors. Something like this maybe. Okay, maybe that's not going to work. So let's say show IP version 6 OSPF version 3 neighbors, yeah. And we can see that our neighbor address is the link local address here. And our neighbor is 1.1.1.1. So if we jump over to Nexus 2, we should see our neighbor as being 7.7.7.7, which is the manual router ID that I added. So show IP version 6 OSPF version 3 neighbor. And there it is. So now that we've done that configuration, we should actually be able to ping 1.1.1 from Nexus 2. So ping 6 1:1:1. And that worked straight away. Show IP version 6 root. And we can see we have the root here. All right, as I've said previously, if you want to see a lot more in regards to OSPF, like default routes and redistribution and different areas, then you need to jump onto the bootcamp. Go ahead and have a look at that at www.routercoach.com. But next up is ISIS.